Davenport hoped to unlock the mystery of evolution.
Davenport wasn't yet thinking much about humans. He was just absorbing all these different theories of heredity and trying to figure out which ones applied when and under what conditions.
After scores of experiments, one theory seemed to stand out from the rest. The recently discovered work of an Austrian monk named Gregor Mendel, who'd spent a decade in the mid-19th century experimenting with peas.
Mendel learned that there was a pattern to how pea plants passed down certain traits. And you could come up with certain ratios to predict how likely it was that a pea plant would look one way or another.
Davenport took that and ran with it. He goes about breeding all kinds of animals looking for the Mendelian ratio. And in trait after trait, he seems to find the Mendelian ratio.
Suddenly, they're beginning to see a mathematical, scientific explanation for things that had been merely conjectural before.
It's becoming obvious that, in fact, there are these things called genes. These units are being transmitted from parents to their offspring, and they're giving rise to physical traits.
By 1906, the work at Cold Spring Harbor had caught the attention of the press and established Charles Davenport as a rising star in the new science of genetics. Thanks to Mendel's laws of heredity, Davenport told one reporter, agricultural breeders could now precisely select for desirable traits to develop a strain of protein-rich wheat or a chicken that laid more eggs. The same methods would one day lead, he predicted, to a rapid and thoroughgoing improvement of the human race.
Davenport was tantalized by the possibility that you could take charge of human evolution. And then along comes Mendelian genetics, which seems to offer a very powerful tool. So extrapolating from the work that the breeders were doing in animals to the breeding of better human beings was a natural step.
In 1909, Davenport informed his funder, the Carnegie Institution, that he'd shifted his focus from the breeding of cats and roosters to an investigation of human traits. Having already found the Mendelian ratio in early studies of eye color and hair color, and convinced he was on the right track, he now began to collect data on a wide range of other human characteristics. He sent out a family history questionnaire to hundreds of individuals